All right, folks, continuing with this problem. Now that we've got our transformation descriptions, we are ready to write the coordinate formula. So which of these transformations are affecting my x values? Just the right two. How do we move our x values to the right two? We are going to add 2 to each of the x values. So again, it's a minus 2 in the equation, but it is a plus 2 in the coordinate formula. Next, which of these are affecting our y values? The vertical shrink by a third. So we're going to multiply all of our y values by a third, and then moving down 1, we subtract 1. So again, those vertical transformations are always a little bit easier. So transforming our parent table, negative 1 plus 2 is 1, 0 plus 2 is 2, 1 plus 2 is 3. There are x values. Then a third of 1 is a third, minus 1, negative 2/3. A third of 0 is 0, minus 1 is negative 1. And then a third of 1 minus 1 is negative 2/3 again. So 1, we go down 2/3, boink. 2, we go down to 1. And 3, we go down negative 2/3. So as we can see from this, this is how each of those 3 points has changed. So does our graph match our descriptions? Has our vertex moved down 1? Yup. Has it moved to the right 2 from 0, 0? Yup. Has it vertically shrunk by a third? All right, folks, so if we look at this graph and we vertically shrink it by pressing on it, that flattens the sides and it looks perfect. Something else that's interesting about this one is if I go up 1 and over 3, I can see that kind of the slope, and I'm going to put quotes around that kind of the slope of this line is 1/3. So I go up 1 and over 3. So there is a relationship between the shrink or the stretch number and the slope when we're dealing with absolute value graphs. And this is something that's going to help us later when we're given the graph and we're trying to figure out our transformation amount. So keep that in mind for later. Let's move on to our domain and range of this one next. Domain is still all real numbers. We can put whatever we want into that number washing machine, but my range from the bottom up starts at -1 with a bracket and then goes to infinity. All right, folks, the last problem of our Unit 3 note packet. Hooray! Now, this one, we're dealing with the reciprocal or the rational function. So describing these transformations, the +3 is on the outside of my fraction, so up 3. That -1 is on the inside or down with the x, so that is right 1. Now, notice that there had been a coefficient of that x, but it's like it's already been factored out, so we're good to go there. But that -2 on the outside of the x is still considered inside of the function. Because it's down in the denominator, it's inside with the x. So both the negative and the 2 are horizontal, and keep in mind that that is 2 separate transformations. The 2 is a horizontal, we reciprocalize the 2, shrink by a half, and the negative is a horizontal reflection. Now, we've talked about how having that negative down on the bottom is really the same as having it out to the side, and which would be the same as a vertical reflection, and the graph would look exactly the same, but just to interpret it, where the negative is located, we would describe that as a horizontal reflection. All right, folks, so now we are ready to turn these transformation rules into our coordinate formula. So describing this one with our coordinate formula, which of these are affecting my x value? The horizontal reflection is affecting x, so we would take the opposite of all my x values. The horizontal shrink by a half is affecting my x values. So we're going to multiply all of our x values by a -1/2. So again, it's 2 in the equation, it's 1/2 in the coordinate formula. And again, folks, it's outside the parentheses, but it is inside the function. And that's always tough when you have those coefficients that have been factored out. Next, we are moving right 1, which is also affecting our x value. So we are going to add 1. So it's -1 in the equation. It's +1 in our coordinate formula. Then the only thing that is affecting our y values is the up 3. So y + 3, easy peasy. So now applying this complicated coordinate formula to our super big amount, 2 points, -1/2 of -1 is +1/2, plus 1 is 1.5 or 3/2. Decimals are fine here because we're going to be graphing those. Then a -1/2 of 1 is a -1/2, plus 1 is a 1/2. Then our y value is +3, -1 plus 3 is 2, and 1 plus 3 is 4. And plotting these points, here's 1.5, 2, and here's a 1/2, 1, 2, 3, 4. And again, that's like literally nothing to go off of. So to actually draw the rest of our graph, we need to apply these transformation rules to our asymptotes. And what's tough about this is we have to do it visually based on the descriptions. So folks, we're going to go ahead and start with the horizontal asymptote. If I take that horizontal asymptote and I reflect it horizontally, that means switching it from left to right. So if I take that asymptote and flip it left to right, has it changed? Nope, it's in the exact same location. If I horizontally shrink it, so if I push in the sides of that asymptote, does that actually affect it? Also no. But sliding it to the left one, sliding it to the right one, that's actually not going to move it either. So none of those horizontal transformations are affecting that horizontal asymptote. But if I slide it up 3, 1, 2, 3, that has moved my horizontal asymptote to that new location. Next, our vertical asymptote. So if I horizontally reflect this left to right, it is still the same line. If we horizontally shrink it, it is still the same line. If we slide it to the right one, it is in a new location. If I move it up 3, it is still going to be the same vertical line. So the only one of these that has affected my asymptote was the moving right one. So there's my asymptotes. There are my points. So I'm going to curve from those points towards the asymptotes. Now, looking at our graph, does it look like this has been horizontally reflected left to right? Yep, that swoosh went over there, and this swoosh went over there. Has it been horizontally shrunk by 1/2? This one's a little tougher to see, but if you squeezed in the sides, it did change the way those swooshes look. Has it moved to the right one? Yep. And has it moved up 3? Also, yes, we can see from our asymptotes. So folks, we are now ready to state the domain and the range for this one. So as we read this from left to right, I'm coming from the left and -infinity is the start of my domain. Where do I have the first break in my x values? At this x value of +1. Where do my x values resume? Union 1 to infinity. And just a reminder, folks, on my math lab, do not use the letter U. The union is a button or a key on my math lab, and you have to have it in between your intervals. So with conic sections, it was all about the commas in between your coordinates, but when we are talking about interval notation, we have to use that union notation. Now my range starts at -infinity. We're going up, 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 and our first break is at 3. Union, we start up again at 3, but parentheses, since those are asymptotes and those values are not included, all the way up to infinity. Congratulations, folks. We are done with our Unit 3 note packet. However, there is one last concept that we are purely going to be covering in the practice set. So in a way, we're going to be doing some notes in the practice set because the only thing we haven't done is taken a graph and tried to figure out its transformations based on the coordinates of that graph. So in the next videos, we'll be doing problems out of the practice set.